Find the area enclosed between the curves y is x cubed minus 3x squared minus 5x plus 7 and y is x squared plus 2x minus 3. Now let's just imagine for the moment that you don't have a calculator available. What we want to do is find the intersections between these curves. So x cubed minus 3x squared minus 5x plus 7 is equal to x squared plus 2x minus 3. Subtract x squared from both sides. Subtract 2x from both sides. Add 3 to both sides. Now, we're going to use the factor theorem. So f of x is x cubed minus 4x squared minus 7x plus 10. F of 1 is 1 take away 4 take away 7 add 10, which is 0. And that tells me that x minus 1 is a factor. So I've got x minus 1 times some quadratic would give me this cubic. Now because this starts x cubed, this has got to start x squared. Because it ends plus 10, we'd have to have a negative 10 in here. I'm not sure how many x's, but now what I can do is use the coefficient of x squared. So negative 4 is the coefficient there. In this one, I would get a minus x squared from here and an ax squared from here. So that would be negative 1 plus a. That gives me that a is negative 3. So what I have is x minus 1, x squared minus 3x minus 10 is equal to 0. So I've got x minus 1. And then we would have 2 and 5. Make this one a minus and this one a plus, and that does the trick. And so we get x is negative 2, 1, and 5 as our intercepts. So as a very rough sketch, our cubic probably looks something like this. Our quadratic probably looks something like that. And so we have two trapped areas, this one here and this one here. This is between negative 2 and 1. And the other one between 1 and 5. Now, along this section, the cubic is the top function. Along the other section, the quadratic is the top function. So, if we were doing this without the calculator, although I'm going to evaluate these on the calculator to save time, I think it's really unlikely you get something quite this difficult without the calculator. So if we're going from negative 2 to 1, so we're in this section, the cubic is the upper function. So what we'd be doing is x cubed minus 3x squared minus 5x plus 7, take away the x squared plus 2x, take 3, and that would give us that yellow shaded area. You could simplify this, of course. We'd have x cubed minus 4x squared minus 7x plus 10. Right, as I say, I'm just going to use the calculator to evaluate that. And so I'll just pause while I do that. And we can see that that comes out to 24.75. Now on the other section, the quadratic is the upper function. So we go from 1 to 5. And this time we'll do the x squared plus 2x, take away 3, take away the cubic. And we can certainly go ahead and just do it like that. What I'm going to do to save myself time is change the limits over. And then I know from my properties that that will be the negative, which means I can just switch these back around, which means I've got this same function again here. So x cubed minus 4x squared minus 7x plus 10. So the advantage of doing that, of course, is that I can just grab that, take it to there, and then just change these limits in here and make that one 5 and make the other one 1, and there we go, 53.3 recurring. And so my total area is the 24.75 plus the 53.3 recurring. And so we'll just do that. And let's change that into a fraction. Oh no, it's not a very nice fraction. Let's change it back again. And just say 78.08 square units. And that's 2dp. Okay, so let's look at doing that in here. I've already got the two functions in. So I'm just going to graph them, and we can see the two areas just like I've got in my sketch. And what I'm going to do here is do the integral of the intersection. So from there, let's go across to there. And you can see it gives me both the value of the integral, but also gives me the area. So it very cleverly takes into account which function is above and below when it does the area